Hello everyone, welcome to Point One Studio. My name is Jung-Hoo Park. Today I'm going to talk about collision-free model strategy. So, have you ever seen any collision-free model? I don't know. If you check with your software, probably you'll always get thousands of collisions. I also experienced same, and I was always wondering how we can make collision-free model. The challenge is all about how you can communicate with different disciplines, like architects and structural engineers, MEP engineers, fire protection specialists. Everyone needs to set the tolerance, so how they can accept some of the collision within the tolerance range. So I'm going to share my idea and thoughts from based on my experience. Maybe there are some improvement, definitely. So by sharing this idea, I would like to also improve some of the rules that I can set in the future. Alright, then let's get started. So here I draft about 16 cases that usually we can make some mistake in terms of collisions check. I don't know many cases you use, maybe Solibri or Navisworks manager to check your model collisions. In this case, it doesn't matter which software we are using, but it's more about how we can set the tolerance. So let's have a look. First example in here. On the left side, as you can see, these are MEP pipes, or you can maybe see the electronic trays or ducts, which anything need insulation of the pipe around. I don't know, maybe you can set that as a collision if you really strict about collisions check. But in this first example, generally, these collisions between the insulation to other architectural element or structural element is kind of acceptable. So I often specify or classify this insulation in another classification in Solibri rule set, and in Navisworks I turn it off the layer and I ignore the collisions from the setting. So yeah, but I do check self-intersection of insulation, so that's the reason why I'm still classified. And when it comes to collisions report, I checking only self intersection and duplicated insulation, because that matter for later quantity takeoff. So that's the reason why. And here, next category is about concrete wall, load-bearing wall, or any masonry wall collisions between MEP components. And I was talking with many structural engineers saying that if the diameter of the pipes is smaller than 300 millimeter, let's say 30 centimeter, then often this collision we can ignore it. But if any openings which has bigger than 300 millimeter, for instance here these duct, they come and it's bigger than 300 millimeter. So in this case, the structural engineer and architect must provide openings to avoid this collision. So that's in case of collision between these bigger element and structural wall, then I report as a collision. And also reinforcement. So even though it's a small pipes, it depends on your model project phase or detail. Perhaps this reinforcement can be matter for these small pipes. So if you can detect the collisions between reinforcement elements, 3D reinforced element to the small pipes, then you can report them as a collision. Yeah. So let's have a look next case. In this case, it's drywall construction, And most of case you have this architectural finishes, plasterboard or any panel, wall panel, and in between you have airspace or thermal layer, which usually in Navisworks or Solibri you don't have this completely empty space. So any MEP system or pipe, they go inside of insulation, it usually detect as collisions, but you can already filter these error from your classification. So classification is a really big, it's really important thing. You have to classify all the component elements clearly so that you can ignore them from the rule set. But basically these collisions, it's not really collision, so in this case you can accept these collisions. So next one is about architectural detail. So of course your model can go beyond ROD 300, or let's say ROG, level of geometry, because I'm talking here more about geometry meta. If that connections or architectural detail is really well modeled up to ROD 400 status, then maybe you can check clearly between the architectural element if there is a collision or not. But generally speaking, most of BIM project, building information modeling project, is complying at the moment with ROG 300 or ROD 300, let's say, level of development. So the detail of, because the level of information could be higher, but level of geometry, most of case, they are happy with ROG 300. So in this case, this sort of architectural detail and the collision between architectural finishes, that can be acceptable, because most of case you are solving this detail error with a 2D drafting view, which goes to the some sort of sensitive, stair details or railing, handrail details. If there's collision, you can make a rule. If you really want to filter all the collisions, maybe these guys going to give you millions of numbers of collisions, so it's better to accept it from the beginning, so you can really achieve collision-free model. Next one, architectural interior wall and MEP system. Let's say the covering, like wall covering or insulation. Before I was talking between concrete wall and the MEP system, but in this case it's architectural wall against MEP systems. As you can see, it's not really a big problem, because the architectural wall, you can cut it out on site. But nevertheless, if there is a big opening such as window or doors, then it's always, it's nice to have openings. And also relatively large openings, if system engineers specify the wall opening including the pipes and ducts, so that they make it big opening, then it's also nice to create opening for the architectural wall finishes. Then you can you can set the rule if the condition, it could be if the duct could bigger than 400 millimeter or something like that, you can report as a collision. Whereas the small pipes going through the architectural finishes or the covering, then you can accept them or ignore from your collision. So you can remove, you can achieve really collisions-free model. Which goes without saying that the floors also sort of same phenomenon. So logic. So if there is a big opening for staircase or hatches or any big opening, then you should be able to avoid the collision by inserting the openings. Whereas if you have small pipes which is smaller than 300 millimeter in diameter, then these kind of collision for architectural finishes in floor, you can accept it. Otherwise you'll have, like in this case, like at least I can see more than 10 collisions, so it's a lot of work to solve these small openings. All right, and now we're looking at the same condition for reinforcement floor slab, structural slab. Yeah, the rule is that you can ignore like the pipes which is like smaller than 500 millimeter, then probably you can accept as a, it's not collision. So, but just bear in mind that you always have reinforcement depending on your floor slab condition. And if you want to filter the collision between reinforced element and these pipes, you can set them from your classification. But generally speaking, if any openings bigger than 500 millimeter, then we definitely have to create openings for the floor, like concrete floor. But if it's smaller than 500 millimeter, you can accept these collision, because on site, more or less, this kind of thing you can drill and make a hole. So it's not a big problem in construction. All right, facade element and architectural exterior wall finishes or roof. You can see here we have sort of angled, window and some openings for the grill or door and windows. These openings must be provided, and you should avoid collision between window and facade element. And so, yeah, definitely these cases we have to provide openings. But if there is a small architectural detail to really delicate modeling, that kind of collisions, you can absolutely ignore it from your collisions report. Okay, let's go ahead for roof and MEP, and it's sort of same as floor system. So if any openings, large openings for duct or roof fan, skylight, or any goes to the shaft area, you can definitely report them as a collision if there is collision with MEP system. But anything like small anchors or any the fire protection element that comes out to the roof element, in this case, if there is collision between roof and these small elements, you can ignore it as a collision. All right. And here the ceiling and MEP components. In this case, I generally accept all these collision in ceiling, even these duct openings. I often don't be bothered to create every opening for the duct on ceiling area. But it's again, it depending on your agreement with your project team. So if certainly some exhausted these sort of duct system that collide with the ceiling area, you can make it opening, or probably you can report as a collision if there is collision, or if the small pipes comes through the ceiling area, you can accept it also from the collisions report. So you make it a bit easier to have zero collision model, which is really big challenge, but it's possible if you make this sort of tolerance rule well in your rule set, then the zero collisions model is really possible. Of course, during the project work in progress, project files, you always have the collisions, but at the end, before you going through the tendering process, it's definitely good to eliminate this sort of collision. But sometimes, even though this small like sort of pipes going through the ceiling, if you really want to check, maybe you have ceiling channels modeled because of your project ROG is higher. So let's say ROG 400, so you have to model all the ceiling channels and suspended ceiling elements. Then in that case, you may classify those ceiling channels to another classification, and then you can make a collision between the pipe and those fitting and fixtures. But if not, if your ROG is 300, then in this case, this sort of small collisions, you can ignore it from your project. I mean, this is again really it's my opinion to achieve collisions free model, but I would like to hear from you some of your opinions. So if you have some better idea or some sort of suggestion or advices for me, then please comment on me down comments Here now we're looking at architectural wall and sort of substrate constructions, like some stud or metal structure in within the architectural wall. This sort of case, it always report as collision, but you can already ignore these collision from your rule set. So any substrate or steel construction within the wall, you can classify as another classification against your architectural wall, and then these collisions can be totally ignored from your rule set. Which goes same for any door jamb or window sill where you have sort of steel construction along the mullions or or this gate area. If there's any collision, that can be reported as a collision, but it is actually not collision. It's just matter of you can check the position of the steel construction comparison to door jamb, and yeah, these kind of collisions you can totally ignore from your report. Another tricky thing is, I don't know, a lot of case steel construction, you don't model all the steel connections unless you specify the higher ROD specification for your project. So there might be some gap between the steel construction, like sort of cut out distance about 3 centimeter tolerance, or maybe there is some collision between steel members. But this happens because your ROD definition, it didn't specify more than 300, or your project is not yet like construction detail or drawing or process of your model process. So it's, let's say, early design development stage, you wouldn't definitely not model all these steel connections. So in that case, you can set your rule that these collisions from steel construction can be ignored. Or whereas if you set the higher level of detail in terms of steel connections between steel handrail, or like between the joint between columns and the beam, or like sort of column plate with all these bolt and nuts, in that case, if you don't specify or classify these steel connection, that maybe these collisions reported as millions of collision in your Solibri model or Navisworks model. So just keep in mind that these kind of hard collision, you can definitely accept it unless there is a duplicate element or some of steel connection is completely within the column. So let's say, I don't know, if your column is like somehow like that look, and if there's any steel connection completely inside of your column, of course in this case it's definitely issue. So you can define that rule to report this as a collision or like some element within the another element, then that you can report as issue, or something completely duplicated elements. So if you have exactly same elements duplicated inside each other, then this kind of report you can make it. So again, classification is very important. So in this case, we can classify first steel connection, first steel construction, and then second steel connections as a second classification. In that case, you can the against steel construction against steel connections, that you can ignore it, but steel connection against steel connection, in this case you can make a rule that to report the error including duplicated elements. Alright, so let's move on. And if you have again the concrete structure against steel connection, in this case you may have lots of steel connectors to join with your reinforced concrete slab, and depending on the rule, these collision can be accepted from your collisions. Just make sure again, if there's any deeper hook from the steel connectors to collide with the reinforcement elements, then that you can specify them and you can accept them, you can, report them as a collision. Next case is again architectural floor with a steel substructure or substrate, same as wall. All this sort of steel structure within the architectural floor, like the framing, structural framing within the architectural floor, that cause the collision between insulation or covering element between the steel structure. All these collision can be accepted or ignored from your rule set, so you don't report them as a collision. Alright, so far this is sort of general rule I'm setting right now for my Solibri rule set, and of course there is architectural element against there are many obvious collisions, like especially concrete element against concrete element, architectural finish against concrete structure, or steel construction against MEP elements, or electronical elements against MEP elements, and etc. But these collisions are very obvious, so I don't think there's something I need to specifically mention here, because the hard collision, they are very obvious. But these rule here that we can accept those points that I mentioned today can be really ignored from your collisions report. Otherwise, you would never get zero collisions report when you make a model set. But there is a very important tolerance setting. Often I set all the domain models, the tolerance about 10 millimeter, or could be 5 millimeter depending on project settings. But the steel construction, I put tolerance of 1 millimeter because this is very critical. You know why? Because let's imagine you have a steel construction. Let's imagine you have steel construction that has I-beam, and you know that the steel profile at the end they are narrower, and then they gradually thicker, getting thicker and thicker. Same here, gradually getting narrow, and then getting thicker and thicker when it goes to the center. Yeah. So let's say in this case, your steel beam profile here, it can be at this point can be already, it's more than 10 millimeter, the geometrical thickness. But when it goes down, it's getting smaller and smaller and smaller. So here maybe that end of your steel profile is just 2 millimeter. In this case, if your tolerance is set just 10 millimeter for steel constructions, that means in case of your lighting, or I don't know, sorry, let's say your lighting device, maybe lighting fixtures here, some of them going, and that collision, because of your tolerance set as a 10 millimeter, even though there is a collision, this collision can be ignored. You know what I mean? So because the geometry here is only 2 millimeter for the steel construction, and maybe some of the fixtures, they are even thinner, maybe 1 millimeter, then this collision can be completely ignored from your report, which is not correct, because electrical elements, they are generally very small and thin. So for the steel construction, I usually set the minimum tolerance to 1 millimeter, so I can ensure that these collisions can be reported from my collisions report. Otherwise, you may miss these sort of collisions from your report. Or if you don't define this clear tolerance setting, then you may encounter with big sort of conflict with your, maybe the client side. They may have a project control company, like project management company. Maybe they'll do their own collisions report, And planner side, we, if there's no agreement and you just set 10 millimeter as your tolerance, and all this collision could be completely ignored from your report. And then the control company, project management company, they set everything to 1 millimeter, and they could report every single collision as a collision and asking you, to the planner's company for all the responsibility, which is really, unfair. So just make sure all these sort of collisions report, you have to set tolerance and these sort of rules and tolerance before you really start to check your model. I think that's most important part for collision-free model. Alright, so I'm just drafting this sort of rule myself to improve sort of Solibri rule set, and also to improve myself to understand construction site better. And I'm just sharing this idea. So there are a lot of things maybe I'm missing or I have to improve in terms of collisions report rule settings. And before setting the rule, these sort of tolerance and which collision is acceptable, which collision is not acceptable, you have to define well, so that you can really achieve collision-free model. For me, collision-free model is sort of ideal model, but without this sort of promise and communication between different disciplines, you will never get collision-free model. When you click the button on software, you may always encounter with millions of collisions. So just make sure that we shouldn't be only controlled by computers, but you have to be clever to avoid or to accept all these sort of collisions in your collisions report. Then at the end of the day, when all the project team working harder for these important collisions, which is not acceptable collision, then we can really achieve collision-free model. Alright, I think that's all for today. I hope this small talk was useful for your BIM workflow. And please, if you have better idea, I really want to get more, advice or comments from you, so that I can really improve my future workflow and also future protocol in terms of my BIM workflow. So I wish you can put some comments on it. Thank you very much, and thank you for watching it. If you like the video, please click on the like button, thumbs up, and also subscribe my channel. That way you can support for me to continue my personal research and sharing this idea. Thank you. Wish you have a good night. Bye bye.